There are many components which make up the drill string, as shown in this graphic. Drill pipe is strong but relatively lightweight pipe. Crew members attach it to a top drive or kelly. Drill pipe forms the upper part of the drill string. Usually, the drill pipe rotates, which also rotates the bit. Each section of pipe is called a joint. Crew members screw together or make up several joints and put them into the hole as the bit drills. Drill pipe, as well as other tubulars, can be specified according to these characteristics: diameter, grades or strength, weights of steel, length. The diameter, weight, and strength used depends on the size of the hole, the depth of the well, and the well properties. Here is a typical oil field tally book. Many of these have sections in them which show standard drill pipe specifications. Drill pipe comes in 3 ranges of length. Range 1 is 18 to 22 feet, or 5.5 to 6.7 meters. Range 2 is 27 to 30 feet, or 8.2 to 9.1 meters. And range 3 is 38 to 45 feet, or 11.6 to 13.7 meters. The most common length is range 2, 27 to 30 feet, or 8.2 to 9.1 meters. Since a hole may be thousands of feet deep, crew members may connect together hundreds of joints of pipe. Drill pipe diameter can be as small as 2 3/8 inches, or 60.3 millimeters. This size weighs 4.85 pounds per foot, or 7.22 kilograms per meter. It can be as large as 6 5/8 inches, or 168.3 millimeters. This pipe weighs about 27.7 pounds per foot, or 41.21 kilograms per meter. However, 5-inch 127 millimeter drill pipe is one of the more common sizes. It weighs 19.5 pounds per foot, or 29.01 kilograms per meter. Normal drill pipe grades are E75, X95, G105, and S135. S135 is the strongest. The rig crew makes up or connects drill pipe, using threaded sections of each end of the drill pipe. These threaded sections are tool joints. The female tool joint is the box end of the drill pipe. The male tool joint is the pin end. Tool joints come in several sizes and types. Tool joint threads are rugged because the crew makes them up and breaks them out over and over during the drilling process. But they have to take care not to damage them. Proper care and handling of drill pipe and other oiled field tubulars can prevent corrosion later in the life of the well. Crew members make up heavy wall drill pipe in the drill string below the drill pipe. Heavy-walled drill pipe, often called heavyweight drill pipe, is made up between the drill pipe and drill collars. Heavy-walled drill pipe is used to provide a transition between the limber drill pipe and the drill collars, which are quite stiff. The use of heavy-walled drill pipe reduces the stress that stiff drill collars put on the drill string. As a result, heavy-walled drill pipe reduces fatigue on the regular drill pipe. It also helps keep the drill pipe in tension. And may sometimes provide weight on the bit, just as drill collars do, especially in directional drilling. Heavy-walled drill pipe, or heavy-weight drill pipe, has thicker walls and longer tool joints than standard drill pipe. The longer tool joints reduce wear on the pipe's body. They keep the body away from the side of the hole. The wear pad also prevents wear. It keeps the middle of the pipe's body away from the side of the hole. Spiral heavy wall drill pipe is another type of heavy wall drill pipe. Spiral heavy-walled drill pipe has a spiral groove in the pipe's body. Regular heavy-walled drill pipe has no groove. But spiral heavy-walled pipe has no wear pad. When spiral heavy-walled pipe contacts the side of the hole, only a small part of the pipe body actually touches it. In fact, only the part of the pipe body between the spiral groove touches it. The groove does not touch the wall of the hole, thus reducing the surface contact area. Reducing the surface contact area helps prevent the pipe from sticking. Crew members make up drill collars at the bottom of the drill string. Drill collars have thick walls and are very heavy. They put weight on the bit to make the bit's cutters bite into the rock and drill. Drill collars range in diameter from 3 to 12 inches, or 76.2 to 304.8 millimeters. They range in weight from about 650 to 11,500 pounds, or 300 to 5,100 kilograms. This particular 6-inch drill collar weighs about 2,700 pounds, 1,225 kilograms. Since the crew usually installs several drill collars, you can see that a bit requires a lot of weight to drill properly. How much weight depends on the type of formation and the size and type of bit, but it can be several thousands of pounds. Drill collars are normally 30 or 31 feet, 9.14 or 9.45 meters long. And have a threaded female connection at one end. And a threaded male connection at the other end. It's an interesting observation that in the drilling business, tubular equipment diameters and hole diameters are almost always measured in inches, but lengths are usually measured in either meters or feet. Some drill collars are slick. They have a smooth wall. Some have a spiral groove machined into their wall. The rig uses slick collars under normal circumstances. The rig uses spiral collars when drilling in formations where the collars may stick to the wall of the hole. Large diameter collars are fairly close to the diameter of the well bore. Under certain circumstances, they can contact the wall of the well bore and get stuck. The spiral in the drill collar helps prevent the collar from sticking to the wall by reducing its surface contact area. Crossover subs go in the drill string between the drill pipe and drill collars, and at other points. A crossover sub has a special box and pin threads. Manufacturers design them to join parts of the drill string that have different thread designs. For example, a drill pipe's pin may not screw directly into a drill collar's box. So crew members make up a crossover sub in the last joint of the drill pipe, where it joins the first drill collar joint. The crossover sub's box threads match the drill pipe's pin threads. And the crossover sub's pin threads match the drill collar's box threads. These matching threads allow crew members to join the drill pipe string to the drill collar string. Drilling rigs typically have a large variety of crossover subs. Crew members often make up reamers and stabilizers in the drill collar string. Usually they place one or more at various points in the drill collar string near the bottom. Reamers and stabilizers hold the drill collars off the wall of the hole to prevent wear on the collars. But even more important, reamers and stabilizers help guide the bit in the direction it should drill. Reamers have cutters on rollers that actually cut the rock they contact. Stabilizers have blades that touch the wall of the hole, but do not cut it. Notice the lower portion of the drill string. It includes the bit, drill collars, stabilizers or reamers, and heavy wall drill pipe. Crew members call this part of the drill string the bottom hole assembly, or BHA for short. They can make up many different BHAs. Which one depends on the type of formation, whether the rig's drilling a straight or directional hole, and so on. The pipe rack is not part of the drill string, but plays an important supporting role. The rig crew cannot put drill pipe and collars on the ground or a deck. Dirt and debris would ruin them, so they store them on the pipe rack. They also clean and inspect the drill string and other tubulars, or pipe, on the rack.